back.
Welcome back to a follow-up episode of the Nerd Club Marionette series. We're with Bruce Thompson and his Marionette.
Well, he doesn't have a
Doesn't
name.
have a name.
I swear he's not a self-portrait, though. I think I had originally intended him to be either the king or the attendant to the king in a production of Dr. Faustus.
Oh my.
But since he never got his costume on, we just have to, he's just a naked puppet. I haven't even painted his eyes in, so he's not even really alive yet. But he's more or less satisfactorily strung now. Last time you saw him, we were still struggling with that.
Right.
Let me.
So where did we leave off now?
Well,
I think
the last thing we didn't get done is we didn't get the hands strung, and now they're working pretty well. Though you notice the string is maybe a little too short, so he's holding his hands up a little bit. Looks a little bit like Jimmy Durante or something.
That's okay.
Yeah,
so and we should mention that this is an unusual stringing system. Your
That's right.
Control.
This is the control invented by Elton Norwood, puppeteer in Denver, Colorado, some decades ago. And I was one of his apprentices, so I learned how to use this system. There are not very many strings. There are two here that go down to the shoulders that support the weight of the puppet. One here that supports his pelvis.
Can we turn 90 degrees so we can see the... There you go.
And the pelvis string may possibly be a little too short because he's kind of holding his pelvis up high. But then one of the changes that I made in Elton Norwood's system is that the hands are on a continuous string, and what that means is that I can control both hands with one string.
Oh, how
they
brilliant.
Still seem to move independently. If I reach across like that, I can do a very elegant bow.
Oh, how nice. Yes. Now, and those are going through eyelets in case that's not visible
That's
on
right,
the camera.
Eyelets right there to there. If I wanted to just control this hand, I could reach over and control it from this side. But normally what I do, since I tend to stand on this side, is I tend to sweep this hand out and still can lift this one up simply by...
Oh, and his hand angle there is actually quite good, isn't it?
It's fairly well balanced, yeah. That's just
Yeah.
a matter of getting the string in the right pivot in the hand. And now, the rocking bar here, which is about the position of the trigger, is what controls the legs. And as you can see, he can walk quite realistically. And one of the things that I think is superior about Norwood's bar is that the legs are back here where they're supposed to be on most... Back him up here.
Yeah.
On most standard marionette bars, the rocking bar that works the legs, they're not on a single, well, there's a single bar, but you have to dip them up and down yourself, and there's a tendency for puppeteers to get them too far out in front of the puppet, which means that the puppet tends to kind of walk out in front of himself too much.
So his balance doesn't appear correct.
His balance doesn't appear correct, where this one, the balance looks pretty correct.
Right. And one of the things that we didn't really capture on film last time that we met was that I was completely amazed that when you're holding the puppet and his feet are touching the ground, you feel in your body his balance, which is completely amazing to me. It's the other mind that human beings have, the ability to project what someone else is feeling, really comes through in the puppet. So being able to walk in balance, I would assume, makes the experience that much more natural for the puppeteer.
Yes, yeah, it's hard almost not to project down and just kind of forget that isn't your body down there.
Right, exactly, yeah.
Now the last feature of the Norwood bars, the strings going down to the head are on these, it's hard to see those because they're behind the hand, the bar that controls the hand strings, but these go down to the head, and because it's the bar is shaped like a gun, wherever you point the gun, the head looks in the same direction, and it can do that without affecting any of the other important strings.
So that's independent of, well, of course, of the walking motion, because the walking motion is controlled by this hinged bar.
In fact, you see as I point back and forth, the bar changes automatically without my even touching it.
Right.
to keep the stance the same, and the hands remain the same because the string slips through the eye holes
Right.
all on their own without my even touching it. The only strings that are being affected in addition to the head are the shoulders and the pelvis, which need to change anyway to account for the balance of what happens when you look in different directions.
Right. So it's really a very natural system, which would probably be better. I mean, it would certainly be easier for professionals, but also would be then that much easier for novices
Yeah,
to learn and get started with.
and since the part of the agenda of the Nerd Club seems to be how would you build servos to attach and do this without human control, the fact that you've got relatively few strings that work relatively independently of each other on the bar but are still integrated in the right sort of way,
Right.
would presumably mean that you have fewer strings to put, fewer servos needed to control what you need to control.
What you need to do, right,
Yeah.
exactly. So yes, it's a nice mechanical simplification that then hopefully ties into automation. So we were talking about doing a jaw on a servo for a puppet, and we were also talking about doing eyes that were either mechanical or there's a system from Adafruit with these little matrix LEDs that actually does very good animations of eyes in a fairly inexpensive little 8x8 matrix, which I've hooked up before. I have some on the way that are the right size, hopefully for a puppet.
Yeah.
And we'll work a little bit more, maybe today even, on having a jaw. Now, having said that, one of the things I just saw the other day, and I'll try to provide a link, was Craig Marin is a fairly famous, actually quite famous puppeteer, and his wife Olga did a lot of work. They actually, and this is amazing. I'll put a link in, but they actually faked on national television one of the moon landings. Now,
Yes.
and this is not a conspiracy theory. They actually really did do it because what happened was this was the moon landing where the lunar camera accidentally got pointed at the sun and was burned out. And so they notified the networks at after they had landed that there would be no live video of the guy getting off the lunar module and walking around on the surface because it simply wasn't possible technically. Well, NBC reached out to a puppeteering company who, on the fly, like overnight, made astronaut puppets. And Craig and his wife actually animated these puppets in order to provide the viewers with something
Visual for the moon landing.
for the moon landing. There was no attempt to say that this was actual, lunar footage. So,
Yeah.
when I say
Any
faked,
more than they are always doing those cartoon animations.
Right.
Actually, I shouldn't call them cartoon, but animation.
of some sort,
Art-
showing
artist-
what the
artist
actual
conception.
right. Anyway, I saw a post from him the other day that indicated that his wife had also animated the Howdy Doody puppet, and what I noticed about that puppet was that it has a string, and I'll point this out. It has a string that comes down right through the head, right through the center of the head, that comes down to a movable jaw.
Yeah, I was going to say that's what I would do. To add a jaw movement, I would probably put a second trigger on this, something that I could pull back from here to tighten that string. Now, my understanding is that the jaw would be held closed with a spring, and the string comes down through the center of the head to below the jaw and pulls it back to open the mouth. So by pulling on the string, you open the mouth, and when you let go and are controlling the string, then it automatically closes because it's springed.
And what's the reason for doing that? Is it because it's more natural for a puppeteer, or?
It makes, well, partly because then you don't have to pay any attention to the string when it's closed. If you had to pull the string to close the mouth, then you constantly have to have pressure on that string while you do all the other strings. So
The
it's
default
easier.
position
It's
is
the
then closed.
Default is closed.
So he's not walking around like a goof with his
Yeah.
mouth open all the time. Right.
But the other reason for that is it's also more intuitive because if you're speaking for the puppet, when you speak, you open your mouth, and so you say something as you pull the string, and that also is more intuitive. Whereas if you had to pull the string to close the mouth,
You'd be doing the opposite. You'd be releasing
you'd be patting
Yeah.
your head and rubbing your tummy. You'd be doing the opposite of what you're
So given that it's possible to do that with a string, is there an advantage to a puppeteer to doing that with a servo? And the only one I can think of is that it can be tied to your actual voice, so that you don't have to.
Don't have to manipulate it with your fingers at all.
Right. When you speak, it just moves the mouth. But other than that, I can't think of a real advantage.
Not necessarily. Yeah.
Okay.
Though.
The other thing I was thinking is I was wondering, and this becomes even more of an issue now that you've pointed out that it was springed to close and you pull it to open, is does pulling that then jiggle the rest of the puppet in a way that is difficult to keep it under control? And I know I'm asking you and you haven't necessarily done this.
Speculating, yeah.
Yeah.
Our puppets, we to get the puppet to talk, you just wiggle the body a little bit anyway.
Right.
You know,
Right.
And
Right.
the mouth doesn't move because we're far enough away and the puppet is small enough that it creates the illusion that the puppet is talking simply by seeing it move when it's supposed to be speaking. All the other puppets, to maintain the illusion, are supposed to stay very still when they're not talking, and they're supposed to look at the puppet that is talking to bring the sight lines in on to draw the audience's attention to where they should be paying attention,
Right.
which is to
And then the audience fills in the motion of the mouth in their own minds.
Exactly. It's an illusion.
Right. Exactly.
But that said, I'm guessing that if you had to if it did jiggle the puppet a little bit, it would only jiggle it enough to make it look like the puppet was talking anyway.
So that's kind of what you want in
That's what
any
you want
case.
anyway,
Right.
yeah.
Okay.
So-
So the whole servo thing may not be useful to
Not necessarily.
puppeteers. Maybe for a beginning puppeteer, so that they didn't have to operate that string and could focus on doing the rest of it. Now, is it very difficult, or did you find it difficult to focus on all the different strings, or is that something that just takes time and practice and then you get there?
It takes a little practice to. The hardest thing is actually, I find, getting the puppet to walk naturally. I spent a lot. You see how I kind of it's easy to take a misstep.
Right.
And I spent a lot of time practicing with the new puppet, learning how his legs were balanced to make, and sometimes learning how to lean the puppet so that he takes a believable step.
Right. Now it does seem like he's leaning forward a little
I
bit
think
more
that's-
than would be natural.
I think that's partly.
Oh, because this guy is a
strings
little
could be-
too.
Yeah, the
short.
strings could be adjusted a little bit better.
Right. Yeah.
This string, I think, should be
There more.
there more.
Yeah.
That would help. So making this string longer and certainly the leg strings shorter would improve his balance considerably.
But then you were saying that getting the walking motion natural is very difficult.
Yeah, that's the difficult part. After that, the head motion is easy because the bar takes care of
Right.
that. These three strings aren't any, they're just weight bearing anyway, and so then it's just a matter of learning your lines and waving your hands so that he speaks with his hands as any good Italian would.
Right. So, and the thing about the legs is that that's exactly the sort of a thing that a computer can help with. If a computer can
Yeah.
track his forward motion, then it could animate the servo to move that bar back and forth.
Yeah, I think I'd be much happier if instead of having to actually walk the thing like this, if I can just press a button that would then cause servos to draw the legs up and down.
Oh, I see. Yeah.
Then I could.
And then you could match his forward motion to the steps
to the steps, right? But the servo would be in charge of
of woggling the bar back and forth.
yeah.
That makes a lot
Or,
of sense.
Or of course, if it was a servo, you'd probably get rid of the bar altogether and have some kind
Yeah,
of
that
up
would
and
be
down
something.
thing.
Yeah.
But yeah, that.
But actually, the other thing about the bar is that it gets those lines where they need to be on either side of his body.
That's the idea, though. I have discovered, I think one drawback to the Norwood bar is there is a tendency to make the bar too short, and the longer it is, the more length you have, and that means the more you're going to be able to lift the knees.
Right.
A mistake that I made on some puppets is I thought I could just get away with a little narrow trigger, and it just meant there wasn't enough leg motion.
Right. So it might be hard to see on the phone, but can you kind of trace, or maybe I can trace with my hand, where it is that those lines actually go?
Oh, where they go, yeah. They are, let's see, here's the end of the, you'll go to the close bar here. Here's the end of the bar, and here.
And then when it gets down to the body,
here,
so it goes right by the side of the body, right by the side of the head.
Right by the side of the head. In fact, you might even mistake it. This is the head string here. It goes beside the head all the way down the front of the body, and then if you were wearing a costume, it would the costume, would go, be like a needle going through the cloth.
Through the cloth. And you have to be careful to make sure that that doesn't then restrict the fabric and kind of give the illusion away.
Yeah, usually it doesn't, but you would have to be careful with that. The idea would be you dress the puppet first and string him later, because you're having to poke the strings through the cloth of the costume.
Right. But this is better for this because now we can see the joints. And I was just about to say, if you fly him up onto the table, I was wondering if we could turn him sideways a bit, or you can just hang him if that's convenient.
Yeah.
It actually works out rather nicely to have something that you can hang him on, because I wanted to get a good shot of the mechanism there on the legs from the side, so that we could kind of understand how that was made. I think we talked about it briefly in the prior video, but we didn't really get a good close-up of it.
They're cut so that here they close like a knee, where here they can go all the way back. Another option on stringing the legs would be to put a second string in the heel here, which would give you the possibility of raising his knee up like this, which right now, you can't do.
I'm trying to think of what that. Well, I suppose for kicking, or the kiss where the girl raises her legs. That's an iconic motion that you can imagine would be.
Yeah, exactly. Or if you were trying to create a puppet that could do something more sophisticated, like actually dance, where this one pretty much all he can do is walk across the floor.
Now, what is the what's the material that's used? It looks like there's two different materials.
I found two different materials worked best. In front, I wanted a thin but strong material, so this is just plain canvas, the same kind of canvas that theater sets are made of. And
handy.
Handy, and I had it around because that's what I made my puppet theater out of. For back here, you could have a thicker cloth, but it really needed to be very strong. It couldn't be something that would tear, because that's what actually tends to break on the leg more than anything, is for this cloth here to tear. So what that is Naga hide.
Nagas gave their life.
Yes.
For this, and then down here on the leg, what you have is just, you're basically just hanging the foot.
Yeah, off of two strips of canvas.
And the rear one a little bit tighter.
Yeah, a little shorter. In fact, almost so short that it's
right there.
Right there.
Yeah.
And then this one longer. And what that does is it allows the foot to move up and down.
Right.
Which creates a very natural walk.
And also to compensate for
the back and forth.
Back and forth, right? Yeah.
Now I should, giving credit where it's due, Norwood invented the control bar. These things I worked out for myself. Norwood's puppets, he instead of using wood, used styrofoam.
On the legs?
On the legs, well, on the entire body and the head, just decided to use styrofoam on the head.
So they would be very light.
Yeah, these aren't pieces of styrofoam. What this is styrofoam insulation. He would create molds and then inject
it, I see.
Styrofoam mold and then take it apart. And he'd make, and then all of the parts of the puppet were held together simply with eye screws. I found when I was trying to duplicate that process that I didn't like the way that would sometimes cause the knees to bend in the wrong way. So I tried to do something a little more anatomically accurate.
Because with this, then the real advantage is that the knee really can't bend very much.
On either side.
This side.
Just as a human knee can't.
And also, it isn't ever going to bend forward, which would look like the puppet was broken his leg.
Exactly. So it locks
but
in
it
place.
does bend nicely backwards.
Yeah.
Up to about the same point that a human leg would. Yeah. So I think this is a brilliant joint that really does a good job as an analog.
And the hip joint, where it joins the hip, it's kind of the same thing. It won't go higher than that.
We can't.
You can pull it really quite.
See, can we just twist this so that? No, like that, right? Okay. So it's more or less the same thing, but with the canvas on the back and the naga
on the front. In
On
that
the
case,
front,
for some reason,
okay.
I'm not quite sure. I think that's yeah, I'm not sure why I thought that was important. I'm not even sure that I did.
Right. Okay. Well, that's a good overview of how the puppet is strung, and we've kind of seen how he's animated it and everything. I'm trying to think if there's anything that we should cover on this one. The eye bolts, of course, for the joints that are on a human being.
Pretty loose and free.
Loose
they're
and
fine,
free,
yeah.
right,
Though again,
exactly.
on the elbows, I wanted something that
Oh,
was...
the waist. Do we want to go over that real quickly?
This is fairly complicated. It's this kind of heart-shaped piece of wood that makes the pelvis. And then on this puppet, what I did was I used naga hide and bolted the chest piece to the pelvis piece. But the chest piece, as you can see, has this very sharp back here point, and the reason for that is so that he can't bend too far backwards, but he can bend as far forward as he likes. And again, that's to prevent him from looking like he's broken his back, but give him plenty of motion in the front.
Now, what you're of course missing from this is that, well, I suppose to a certain degree he can. Oh yeah, I see. He can turn left and right.
A little bit, yeah.
Just because of the slop in the
naga hide.
naga hide. Yeah. So that's again a pretty good analog of what a human can do.
Yeah. Now those motions, none of those motions are controlled by the control bar. Those are just things that the puppet is going to, because of its own balance, do more or less naturally.
A form of automation.
Yeah.
In itself.
Yeah.
Yes, exactly.
And in fact, I've never been necessarily that good at it, but master puppeteers understand that most of the motion of the puppet should come from the balance of the materials from which it's made, and relatively little of it should come from the control of the strings. The puppeteer is learning how to balance the puppet, not how to control every single motion.
And it should hopefully be visible that I think in the first video we had the string attached here.
And the hand fell too far forward and didn't look good.
Right, and when you were trying to raise it up, it was coming up like that instead of So now you've taken it out here and moved it up here onto the finger, just because the weight of the hand, it ended up having the balance at that location.
Yeah, you have to find kind of where the fulcrum point is on the hand. These are fairly heavy. This is made out of plastic that's been cooked in the oven, so it's a fairly heavy material, and it tends to have a heavy balance. So.
And is that generally good, or would you prefer to have something lighter?
I don't. I think I like it a little heavier. Things that are heavier, well, they take more work to lift, tend to flow more naturally when you get them in motion.
When you're moving them.
Yeah.
Right. That
And
makes
so
sense.
I don't mind having heavy hands, because it's the heavy hands that give the puppet a certain amount of gracefulness.
Right. Exactly. That makes a lot of sense. Okay, well, that's probably a good stopping point for today. Next time around, we'll have the electronics for the eyes, and hopefully be able to start showing that off. We'll start on a new puppet head.
Okay.
And we can play around with servos, either on jaws or on whatever. Thank you, Bruce. Much appreciated.
Welcome.